This conference will now be recorded.
So yeah, the swap we used to be get utilized only when your RAM is flooded. So we will see that how we can add a swap space in a running system.
Excuse me, sir.
Yes,
Sir, Sarvajesh is waiting, sir. Is my friend.
server.
He's also new to join.
Okay, so he is waiting where?
In the meet to allow you, you have to allow him to join the session, sir.
I don't understand. He's waiting, but he's waiting where? Is he in the lobby? I can join him
Yes,
by
sir.
clicking
He's in the
somewhere.
lobby, I guess, sir.
I don't see anything. Let me see whether it's visible to you that he's waiting in the lobby.
Sir, he sent me the screenshot, sir. It is showing waiting for to join the session.
I think he's in another call. Maybe the link is
Okay,
different
okay, sir.
because
Let
you're
him
not
know,
able
sir.
to join. You can send the link whatever you are having, and he can give a try to join.
Okay, sir.
Yep. So I was talking about swap space. So let's go through the example that how we can add the swap space in a running system. So I do have turned on. Just 1 second. Mm, I need to share this virtual machine application, and in that I can search for the settings, machine settings. So for swap space, if I do need, I need to create a free space, and that free space has to be get formatted by the uh, for the swap partition, and then I can add. I need to flag that particular partition for the swap, and then make it turn on. So what I can go ahead and do. This screen is visible. Is it correct? Am I correct? The menu, the setting menu, whatever I'm opening right now.
Yes, sir.
Mm-hmm. So I cannot modify anything since system is running. So let me turn off this and then open the settings. This is the setting for this machine, and I'll go to storage. I will add one more extra disk. No, I don't want controller. I just want a hard disk, which is, let's say, 2 GB. No, I don't want to search. So I'm just creating an empty space, and I'm going to use this swap space. You can see that here. I'll press OK. I'll start this virtual machine. So fdisk space -l is going to give me the list of partitions. So center swap seems to be it's not mounted, it seems. But why it shows mounted? SDA, SDB, okay, this is fine. Let me see here. SDD 2GB, okay, that has been marked as SDD here. So let me format, okay, let me try by just giving the command whether it is able to create the swap or not. It should not say that unrecognized partition. If it's going to say that, we are going to format it in any file system format /dev/std. Setting up swap version, this no label uuid. So we have the new swap cat lock swaps. So this was the only one which is currently in use. We can see the swap space like this as well. It will show here the swap 2097148. It seems to be like 2 GB. It's all free. So swaps, it's going to show us this device has been mounted as swap. So now we have formatted one partition as swap. Now we need to make it turn on. Swap on is the command STD. Now we will see we have STD as well. Now you can see that as we have turned on, this is going to be get utilized as swap as soon as this partition is going to be get filled. If first one is going to be get filled, another next swap is again going to be get used. So we have seen that how to mount a swap partition in a running system. And if you want one swap to be turned off, you can turn it off from here. You can see that it's not going to be get used. So this is all about swap. And before going ahead with RAID, I wanted to make you to understand that what is MBR and what is GPT actually. So GPT is GUID partition table and MBR is a master boot record partition table. And MBR has been used by from the starting time when DOS and before DOS also it was there. So MBR actually the specific thing about it is having a master boot record installed in the starting sectors of the disk, which gets executed and loads the big bootloader after that, and then the bootloader subsequently loads the different components of the kernel and operating systems, and respectively it goes further. So that's what the MBR is, and there are some limitation with the MBR. The limitation with MBR is like either you are using that in Windows or in Linux. Both does have the limitation. The limitation is like you cannot have more than 4 primary partition in it. And if you want more than 4 primary partition, you are required to, sorry, you cannot have more than 4 primary partition, but if you want more than 4 partition but not primary, then yes, you can have it. So the way to do that is like one partition you are required to convert that in extended, and then after that extended partition you can create a logical partition out of it. So all these things you will be able to see when you create a partition table from your Windows. but please don't try if you have your Windows installed on your desktop. You can give a try in your virtual machine. Why I'm saying this is, let's say if you have created more than 4 primary partition, and you have shut it down your system, and if you restart your system, then you will not be able to boot at all, and you will not be able to install operating system also on that. So ultimately what you are required to do is, once again you have to boot with Linux. You are required to format all the partitions, convert them into, or create a new MBR partition, and after creating a new MBR, you are required to install once again a fresh Windows on the top of one partition. So please be aware, when you are partitioning more than 4 partition in a Windows, please be aware of it. You should not do that. If you are doing it, please do it in a extended and logical partition. This is all about MBR. And yes, you cannot have more than 2 TB of hard disk in MBR. The reason for that is the way MBR divides its sector, the way MBR allocates the memories of the disk, it can extend only up to 2 TB, not more than that. So that's another type of limitation it is having. So in another way, I can say that the MBR can map only the disk which is of 2 TB. It cannot map more than that size, the way it handles the memory. So this is about MBR, and GPT partition. It's GUI. It's another type of. The difference in between these two is like the way they handles the memory, or the way they store the data, because each partition, even though if you talk about not even MBR GPT, if you're going to talk about, let's say in Linux system, if you're going to talk about what is ext3, ext4, ext5, and xfs, what are all these file system types, and the differences in between this, the major difference or the key difference in all these partitions are the way you are going to handle the memory, and where you are going to store all the mm, all the all the blocks, whatever you are going to write, and how you are going to access them. In some places, you are going to write down from starting, and then you are going to till end. At some in some partition type, you are going to write uh, from end, and you go proceed further with the starting. So whenever we write down on the disk, we keep a copy of the date, not data, but the link in a metadata also, which is going to store at the starting of the disk. So what does it mean by that? Whenever you go to that particular file system, if you are going to access one, you will have, if you're going to access one sector, you will have the link of another sector linked with that particular what to say, the sector number, that this sector is going to be linked with further blocks. So my point here is, like, whenever you say that one you are formatting your one drive in a particular format, it means like it is going to have a metadata at one place, and the way it's going to fetch the data with the help of that metadata, it's going to be different in all of the partition types. That's what the major difference here it is. And yeah, in EFI, sorry, basically this MBR partition, what I told, it's sorry, not MBR, GPT partition, it's made for UEFI kind of partition tables, can be get UEFI, I can say that it's utilized by the UEFI more, and which replaces the old BIOS with something more modern. And What more I can say is like you can have more than 2 TB of hard disk, the major difference, and you can have more than 4 partitions, but you can have up to 128 primary partition if you are formatting a drive in GPT. Yeah, GPT. You can have up to 128 partitions, which generally people don't do, but yeah, it can support up to that. So this is for the basics of GPT and MBR. So as we move on to the RAID, let me tell you, there are different type of RAID. What is RAID actually? RAID is redundant array of which disk? Uh, Inexpensive disk. So it's like we will have the disk, and inside those disks, how we are going to divide our data, so that whenever we need over the time, if we lose, if we fail, if my drive is going to be get failed, then in that case I should be able to get the data. So that's the whole purpose of this RAID, is how to get the data whenever we lose a disk. So for that there are different kind of RAID mechanism available: RAID 1, RAID 2, RAID 0, RAID 0, RAID 1, RAID 2, and further as well. RAID 2, I'm not sure. RAID 0, 1, 5, 10, and 1, I have seen. I have most of the time I've used RAID 1, and there are two type of RAID comes in terms of, one is hardware RAID, another one is software RAID. When I call about when I say about hardware RAID, it means like we are having two hard disks and there is a separate controller sitting on the top of your motherboard that can be controlled from your BIOS to create a RAID and delete a RAID and to perform different operation on the RAID. We are going to call it as a hardware RAID. And when you say software RAID, it means like we are having two disks, but we don't have any options in the BIOS, since we don't have any controller. So here in software RAID, you're required to install a software, and that particular software is going to create a RAID file system out of those two hard disks. This is what the meaning of RAID here. I'm sorry, I have just taken example of RAID along with two disks. You may have several other disks as well. Let's say you want to have a disk with three drives. You want to have a disk with 4 drives. On the top of that, you wanted to create a RAID. Yes, for sure, you can go ahead and create a RAID. So generally, I'm going to take example of 2 drives. Out of 2 drives, I'm going to create a RAID partition, RAID 1. So what is RAID 1? RAID 1 basically is, okay, I'm going to explain RAID 1, and the remaining RAID I want every other person to explore on their own and understand what is the difference. If you still feel that you don't understand and you need any explanation, you can come back to me, I'll explain it. So RAID 1 is like copying data in one drive, and at the same time you are going to copy the same data in another drive. So in another word, I can say that you're copying the same data in the two disks simultaneously. That's what is the meaning of RAID 1 here. So for that, we are required to have two disks. And after that, we are going to format the procedure for that is we are going to have two disks. We are going to format that with or both the disks using with MS-DOS flags. And after that, we are going to create the partition out of it. And after creating partition, we are required to install the MD Adam software, which gives us a privilege to uh, install or to create the RAID out of those two disks, delete or do some different operation on the top of those two disks. So let's start that. We have SDB1. Okay, here we can see that SDB1, STC1, which is 8 GB and 15 GB. So SDB1 is allocated for quota, and STC1 15 GB is simply lying down. And SDD we should have stopped the swap. Let me check. Oh yes, we have turned off the swap. So let's use SDC and SDB. Let me see if we are able to use SDB or not. Okay, so what I was trying to say here is, let's say if you hit something like this, we test dir, it's a directory, where the message. So you hit something like this, and here you can see that you have two things. I have just now opened the dmessage file, and I have simply exited the dmessage file without closing it. So it goes to .dmessage.swap. So it gets renamed. It means that the file is still open somewhere. So whenever our file is open, it's going to be get created one extra file with this swap swp, and the temporary information whatever you are writing, it's going to be get saved here. So let's say if you know that you are not writing by mistaken, something would have happened, like you have already opened that particular file somewhere and then you restarted the system, so the file is still there. So in that case, you may see like this: found a swap file by the name .dmessage.swp, owned by root and all these things. It has been process ID is still is 1595 still running. So if I reboot the system, it's going to be the same. And how to come out of that thing is, you are required to, sorry, you are required to delete that particular swap file. Oh, it's got deleted. The reason for that is that was still running. So one thing I can showcase you that if it's still open and if I simply reboot. Mm, do we have? No, I think it's getting cleared. Okay, it's getting cleared. In some cases, we have seen that in FS tab, I might have closed by mistakenly, and that was still left behind. So we can simply remove that rm-rf dot whatever the file was there. But please don't delete these files. Bash history, bash logout, bash profile, bash rc. These are all important files related to your uh, own user. So please don't delete all these files by mistake also. So okay, so I have deleted that and I have formatted one partition. Let me format another partition. STB, STC. Do I have anything for that as well? STC, no, I don't have anything. Okay, it's all SDA, fine. So we do have SDB and SDC, which is 8 GB and 15 GB. And I'm going to use both the partition to create a new partition. So for that, I'm going to use utility fdisk space /dev /sdb, and then n for creating a new partition, p for primary partition, and 1 is for the number which I'm going to give by default. So sector size, I want by default last sector. I want all the disk size to be get utilized. P will give me the options for printing and seeing what is there. We are required to change the partition type, so let's type T. And for RAID, we are required to give the hexa number is FD, which is going to change our file system from a normal Linux to Linux RAID. And then once again, we'll see the partition type. So now it has been changed from Linux to Linux RAID. And then we are going to press W, which is going to get written. All the things, whatever we have done, it has not been yet written. So if we write W, then only all the things is going to be get performed on the actual disk. If I simply exit from there, it's going to exit. It's not going to perform anything, whatever we have done so far. So this was for SDB. Now let's see SDC. We are going to do the same thing. Sorry, not this. Create primary partition 1, use all the disk. Then let's see, it's Linux. Then I need to change the hex code to Linux RAID. Now we can see that it's Linux RAID. Now write it down. We can see that SDB is Linux RAID, SDB1, SDC1 is again Linux RAID auto detect. So after that, when we see both are Linux RAID, we are going to install yum install md adam. Is it md adam or adm? I think it's md adm. Yeah. So this is the utility, or I can say software RAID utility. I'm going to install it. Now I want to give this first of all, I want to examine both the two partitions. Which is type FD, and we see FD means like Linux RAID, and we can see that it doesn't have any issue. It's not showing anything. If we do have any problem, we might see that. Okay, let's examine SDC1 and SDB1. It shows we don't have any super block detected. Yeah, we don't have because we have not created yet. So now let's create a RAID out of this. So command I'm going to use is mtatom --- create dev / md0. md0 is a name of a partition which is going to be displayed for you to read or write data in it. Level is mirror RAID device equals to 2. We want to create with 2 devices, and the device names are /dev /SDB1. Why it's not typing? /dev/dc1. Yeah, it's throwing the warning that it cannot be suitable to boot and throwing some lots of information about it. 1% is it's throwing us okay. Here one more information I wanted to say, that when we are creating a RAID, okay, let me finish this creating and then I will tell you other information. What I wanted to say here is okay, so we can see that it's varying. I'll come back what it is doing. So let's say we have three disks. One is 7 GB, another one is having 10 GB, and third one is having 15 GB. And we wanted to create the RAID out of all these three disks. So when we create the RAID one, I'm talking about RAID one. When we create the RAID one, it's going to use the minimum size of the disk was 7 GB. So it's going to create the RAID one with 7 GB of volume. So let's say if I'm having 8 GB of SDB1 and SDC1 was 15 GB, so it's going to, whatever the MD0 we have created, it's going to be around somewhat close to 8 GB, the minimum size, whatever we have. Just 1 second, please. Hold on. So yeah, sorry for that. So whatever we see here is after creating RAID, it's showing that it's going to sync with another disk. So disk one is going to be get synced with disk. So disk two, it means like the disk one data is going to be get copied with disk two. So here we see that it's syncing. Previously it was 6.6, now it's 9.0. Maybe it would have been completed so far. Okay, it's still writing the blocks, and it's 74% is completed. So let this go through. We'll see that the detail of whatever we have created. It's showing that we have created the creation time and RAID one, and you can see that 7.99 GB, 8.58 GB around. So it's around 8 GB, and RAID devices is 2, and super block is persistent. Active devices are 2, working devices are 2, failed devices and spare devices. Failed devices means like some devices has gone offline, or it has got some bad blocks or bad sector, or somehow the device is not working. Operating system is not able to write into the device, or operating system is not able to read data from the device. So if that happens repetitive, operating system is going to mark that particular device as a failed device, that I cannot operate with that particular device. So that's one thing. A spare device is like, it's the same. The meaning of a spare is literal here, like we have something in a spare and we will utilize it based on our need. So, here we do have the same meaning. Spare device means like we are having one device which is plugged in as a spare device. When we plug in, when we mark that particular device as a spare device, that's going to be get displayed here in spare devices. And the use is whenever we remove, let's say one device, or one device is going to get failed, this spare device automatically comes into the picture, and it automatically copies whatever the data we were having on disk one onto the disk two again. So that's the purpose, whole and sole purpose of this spare device. All the data automatically is going to get copied whenever we do have any failed device status of one device, or when we plugged out one device which is part of the RAID system, RAID 1 system. If you plug it out, so automatically spare device is going to take and became a member of that particular RAID 1 volume, and then it's going to be get copied all the data on that. So that's what we see here, and I think that's it as of now. I can share one link which is